Deep in the cosmos, past the familiar spirals of our Milky Way galaxy and further than the eye or any telescope can see, lies a monster. A mysterious monster we've yet to meet but know is there. Located 150 to 250 million light years away, this dreaded space anomaly known as the Great Attractor is busying itself with a gravitational pull so strong and all-consuming it can pull entire galaxies into itself and against each other. So how is it that we are aware of the Great Attractor, yet have little visible evidence for its existence? Though its true nature is still shrouded in mystery and there is much to learn about the Great Hoover in the sky, 1970s astronomers were able to trace its whereabouts via detailed maps of the cosmic microwave background, or the CMB. The cosmic microwave background provides a snapshot of the oldest light in our universe. It is the residue left from the Big Bang and marks the transition from a period of density and heat to transparency and light. Space scientists had to find cause for a discrepancy in temperature discovered between one side of the Milky Way and the other, albeit a mere 1/100th of a degree Fahrenheit. Though it might sound infinitesimal, the finding of this discrepancy in heat, referred to as the CMB dipole, indicated the existence of something that influences the movement of all galaxies. And so, the tale of the Great Attractor begins. Stay tuned to learn more about this monstrous mass, how it sits in this great cosmic soup obstructed from view by space drunk like an obnoxious theater goer, and whether this pale blue dot we call home will be crossing its path anytime soon. Part 1. The Zone of Avoidance. Why we can't see the Great Attractor. Generally speaking, astronomers are pretty damn good at looking at stuff in space. Large-scale structures and cosmological theories have been fantastically mapped and evidenced. We have substantial reason to believe in the Big Bang as the leading theory for the universe's beginnings, only bolstered by 2021's launch of the James Webb Space Telescope. We have known about dark matter since Fritz Zwicky, the Swiss astronomer, discovered an unseen mass in 1933, originally termed Dunkelmaterie, aka dark matter. We even have observations of interstellar objects, such as the first recorded interstellar object which looked like a giant cigar and was given the glorious moniker Oumuamua. However, there is an area within space which is particularly difficult to observe. This area is known as the Zone of Avoidance, a region we struggle to access because it requires us to look through our own galaxy. And you guessed it, the Zone of Avoidance is exactly where the Great Attractor is situated. The Great Attractor lies in the direction of the constellation Centaurus and our Milky Way's disk, which puts a big old line through our observational capabilities. Not to mention the fact that our galaxy is jam-packed with not-so-jammy junk, from space debris to stardust to the remains of Ham no longer on the moon. Is hope of unearthing the mysteries of the Great Attractor on the horizon? Following its initial discovery in the 70s, astronomers proposed two potential avenues to find out more about this inky yet instrumental area of the cosmos. The first option would be to wait for the solar system to orbit the Milky Way until we are in a better position to make observations. However, whilst there have been some interesting breakthroughs in the field of genetics, it would take around 100 million years for us to have a better view, just slightly beyond the wait time of the average grant funding cycle and human lifespan. So, that plan went into the bin along with all the nanosatellites running rings around the stars. The second option would be to turn to alternative wavelengths of light to make observations, such as X-rays and infrared. Whilst X-ray light is particularly good at penetrating dust, it only shows us incredibly bright regions of space, such as star formations. Infrared, however, is more adept at peering into even greater distances, as we have recently seen with the incredible high-resolution images coming from the James Webb Space Telescope, like this bad boy. Since the 1990s, astronomers have been trying to make observations within the zone of avoidance by performing infrared and X-ray surveys. In the mid-90s, Australia's Parkes radio telescope was able to detect numerous galaxies and galaxy clusters we were previously blind to. In 1996, a team of researchers led by South African astrophysicist René Kraan-Korteweg discovered evidence for a supercluster within the zone of avoidance, Abell 3627, also known as Norma Cluster. Since X-rays are emitted by galaxy superclusters and can pass through the opaque galactic plane, Norma Cluster was able to be observed. This gargantuan supercluster is believed to have a mass of 1 quadrillion times that of our Sun. As impressive as this finding may have been, indicative of the Great Attractor's potential as a supercluster with Norma Cluster near its core, the team fundamentally didn't observe the Great Attractor itself. Part 2: Where exactly is the Great Attractor located? Though astronomers are yet to make direct observations of the Great Attractor, we have been able to ascertain its approximate location. To get to grips with its whereabouts, let's start off with our home. Planet Earth is part of the Milky Way galaxy, which stretches for approximately 100,000 light years. Our neighbor, if you will, is the even larger galaxy named Andromeda. Together, along with Triangulum, the oft overlooked underdog of the galaxies, we comprise the local group. In time, a few billion years away, just a bit further off from your great-great-great-granddaughter's birthday, members of the local group will merge together like space mafiosos into a single mega galaxy. This mega galaxy will hurtle inevitably toward the big boss in the sky, known as the Virgo cluster, comprising over 1,000 individual galaxies packed into a ball spanning 5 million light years across. Sort of like a moth to the moon or a teaspoon of iron fillings to the central solenoid magnet. Neither of the above are accurate ratio-wise, but nonetheless, we are drifting into a huge mysterious mass far larger and more powerful than the human mind can comprehend. The space relay will only continue as the local group is thought to move beyond the Virgo cluster and into the Virgo supercluster. Astronomers once considered the Virgo supercluster as the largest neighboring structure to us in the nearby universe. However, after conducting extensive surveys within the zone of avoidance, an even larger structure was found. This structure was aptly named Laniakea, a Hawaiian word that roughly translates to immeasurable heaven. Slam dunk in the middle of Laniakea and estimated at around 150 to 220 million light years from the Milky Way sits the Great Attractor. Despite its mysterious nature, astronomers are confident that we are heading towards the Great Attractor. Part 3: Will we ever be crossing the Great Attractor's path? The Great Attractor is our fate. It is our future, but will it be our ultimate end? Whilst the motion toward the Great Attractor will accelerate, the distance between us and this mysterious region is growing at an even faster rate. This phenomenon is called cosmic expansion. The cosmic expansion also makes it even harder to see areas within the universe. So, any hope of observing the Great Attractor directly is largely considered by astrophysicists to be out the window. The universe's expansion will, in the end, win out against the gravitational attraction our galaxy has towards the Great Attractor. We are still running, but the treadmill has been turned up so high we will collapse and die of a heart attack before we finish the race, so to speak. Many astronomers believe that before we get to meet our nemesis, it is likely that dark energy will tear the universe apart. Whether or not the fate of the universe will come not with a bang but a whimper is yet to be said, but either way, being swallowed up by the Great Attractor is certainly off the cards. Besides, we have other more immediate concerns to think about. Perhaps the death of the sun in 7 to 8 billion years, perhaps a giant asteroid obliterating the Great Wall of China until we are a mere hiccup in the history of the universe. With every second that strikes, we are being pulled by the mass of 1,000,000,000,000 suns towards the Great Attractor. But not to worry, we'll be wiped out by some other mesmerizing terror in space before we get there. Sleep tight, kids.